Alright, welcome to using parallel and perpendicular lines. First thing that we're going to do is take a look at this problem where there's a slope provided in this line. Since our new line needs to be perpendicular to this line, our slope needs to be what's called a negative reciprocal. Since this slope is equal to 4/3, my new slope will equal negative 3/4. That is because you flipped the fraction and you also negate it. So if it had been negative, it would now be positive, but since it was positive, it is now negative. So 4/3 becomes negative 3/4 for my slope. Now I'm going to consider this point, x and y. I'm going to write all this down. Y equals mx plus b. And now I can actually have a few values I can plug in. Y is negative 3. M is negative 3/4, as I've already mentioned. My slope times x, which is 4, plus b. Now all I got to do is figure out what my y-intercept is on this problem. So negative 3/4 times 4 would be negative 3. Add the 3 over, and I'll get 0 for my b. So my equation, I now have both things I need, the slope and the y-intercept. Y equals negative 3/4 is my slope, x plus 0. Since it's 0, I'm not going to bother writing it, but this is the answer for the line that would be perpendicular to this line and containing that point. Moving right on into example 2. Find the distance from the point negative 1, 6, which is right here, to the line y equals negative 2x. So I'm going to graph the line y equals negative 2x really quick. Remember, down 2 over 1. 0 would be our y-intercept for that line. Just to be nice and neat, I'm going to use a straight edge to create that line. And here we go. Alright, next thing, I'm going to consider a slope that is perpendicular to negative 2x, because the distance will always be perpendicular to where the point is. So when I'm writing this, I know that my slope will be positive 1/2. If you're confused about that, that's because negative 2 is my slope, so it's negative 2 over 1, which will become positive 1/2. So from this point, I'm going to rise 1 and run 2, so 1/7 is a coordinate on it. I can also go down 1 to the left 2. There we are. And I'm going to graph this line out. But my final answer will simply be this distance right here. Now, in order to calculate that, I must find this point of intersection. My calculator would be pretty helpful with that. I'm really quick going to write the equation for this new line as y equals 1/2 x. Again, my slope was positive 1/2. Plus 6.5 is where the y-intercept would be. I think the easiest thing to probably do here is actually use your Desmos graphing calculator. So that's what I'm going to do really fast. And I'm going to be typing in those two equations. So y equals negative 2x and y equals 1/2 x plus 6.5. Alright, now once I've done that, I'm finding the distance to this point right here, which is negative 2.6, 5.2, which again is representing this point of intersection for those two lines, and I'm finding it to this other point. So these are my 2 points I'm needing to find the distance between x1 and y1, x2 and y2. So really quick, distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. All I got to do is plug these values right in. So distance equal, does not matter which one's x1, y1, and x2, y2. Just plug them on in. So I'm going to do negative 1 minus negative 2.6 squared plus, I'm going to do 6 minus 5.2 squared. Since I'm allowed to round here to the nearest tenth, I'm actually just going to type all that into my calculator at one time. So you're going to see me grab my Desmos again and type in this whole expression. And we'll pause it while I do that. So I'm typing in the square root of parentheses -1 minus -2.6 close parentheses squared plus parentheses 6 minus 5.2 close parentheses squared. Doing that all at once gives me 1.8 to the nearest tenth. Distance from the point to the line is approximately 1.8 units. That wraps example 2. We've got one more to look at. The other kind of problem you can be faced with is finding the distance between two parallel lines. So on this problem, first thing I'm going to do is going to quickly graph both of them. Y equals 1/2 x minus 2. Start with the minus 2, which is your y-intercept. Go up 1 over 2. And go ahead and make your line for that line. Alright, now for the second one, has the same slope because they are parallel. 1/2 x plus 1. 1 is my y-intercept, and again up 1 over 2 each time for my slope. I'm going to go ahead and draw my line in right here. Now to find the distance, I pick a point on either line. It's usually easier if you make it a y-intercept. So what I'm going to do is be considering this point of 0, 1 right there. That's the point I'm going to work off of. I think that's just going to be the easiest thing to do. Like I said, go with a y-intercept. It's going to be easier. Now what I'm going to do is create a perpendicular. Since my original slope was positive 1/2, I'm going to flip that fraction and negate it. So -2 over 1 is my new slope. And so I can go down 2 over 1 and make a perpendicular between the two lines. Alright, now what I'm having to do next is I need to figure out what coordinate that is so I can use distance formula. In order to do that, I'm going to create an equation for this perpendicular that I just made. It's actually pretty easy. I already know my slope. Also, since it has a y-intercept of 1, I know my y-intercept. So y equals -2x plus 1. That was the reason why it was easier to use a y-intercept there. Now, I need to compare that to the equation 1/2 x minus 2. So what I'm going to do is I'm going to type this one and this one into my Desmos calculator to see what their intersection is, so I know what point to use in my distance formula. So you're going to see me type in y equals 1/2 x minus 2, and in the second box you're going to see me type in y equals -2x plus 1. Once I've graphed those two, I do see this coordinate right here is 1.2, -1.4. Now that I know that coordinate, I can simply use distance formula to figure out how far apart the parallel lines are. So, distance equals the square root of x1 minus x2 squared. Doesn't matter which value is x1 and x2, again, as a reminder, plus y1 minus y2 squared. I'm going to square root all that. So now, let's take a look. Distance is equal to, all I got to do is just drop these values in. So I'm going to do 0 minus 1.2 squared plus 1 minus -1.4 squared. If I see people make a mistake, it's because they just put minus 1.4 where it was clearly minus -1.4. So do watch out for that. You might have made that mistake on the previous problem if you were trying to follow along. Now that I've done all this work, I can actually go back into my Desmos calculator and type in that expression to see what my answer is to the nearest tenth. So square root of 0 minus 1.2 squared. You can see I put parentheses around it like I should, plus 1 parentheses 1 minus -1.4 close parentheses squared, and I'd get 2.7 to the nearest tenth. That's a wrap for my examples today. Just really finding the distance from a point to a line or between two parallel lines. If you have questions, definitely contact me through email, or if you can send a message through Classroom, that's fine too. Just let me know what I can do for you. Thank you.